So as I mentioned in the last video, I was planning on doing another amplifier kit build, and I'll provide a link to this one. This one comes from eBay, and it's about 18 bucks. It claims to output 70 watts, and I have seen evidence, at least in online articles, that it's able to achieve at least 45 to 50 watts. So this is the kit, what the kit contains. Unfortunately, I thought that all the SMD components were supplied too, and you had to put them on. Unfortunately, they're already on the circuit here. So there's a voltage regulator here, as a PNP transistor and some caps, but they've already all been installed. So what you get to install is what you're seeing here. So this is a push-pull amplifier with a pair of IRF 530s, which you can see here. This is a simple receive-transmit relay. Is a pair of 100 ohm, I believe they're 2-watt resistors right here. A couple of 100 microfarad electrolytic caps, and then these are, there's two binoculars. I believe these are 43202s, and then there's a pair of these ferrite tubes which you use to wind the big, the final output transformer. So it does provide some heat sinking hardware. So you've got these sill pads, these insulating bushings here. It doesn't come with a heatsink though. You have to provide your own heatsink, and there's a couple of SMA adapters and some wire that is also provided. So let's go over and have a look at, I've drawn the circuit up in Kicad, and let's have a look at that.
Okay, so here's the circuit drawn up in Kicad, and as you can see, it's pretty straightforward. Let's just go through it. First to the power supply circuitry. And you can see here, this is the main power supply here. There is a PTT switch which pulls to ground on transmit. When you pull to ground on transmit, it turns this PNP transistor on, and then that in turn turns this 5-volt voltage regulator on. And this 5-volt, through this 5-volt voltage regulator, there's a trim pot here which supplies bias to the gates of the IRF 530s. Just moving down to the IRF 530s themselves. So you can see here on input, there is a simple relay which is turned on by that transmit on. This transmit on here comes from the PNP on grounding of that PTT jack. And then, so in no transmit mode, this relay effectively just routes the incoming RF to the out. So basically, on receive, that the RF just passes through here. On transmit, basically the RF incoming gets directed to this this amplification circuit here. So we've got the sort of classic splitter arrangement here. Splits it into phase and anti-phase signals, and then you have a pair of IRF 530s configured in push-pull. This is that pair of ferrite tubes, and here's some feedback circuitry right here. And now I'll include a link to this this Kicad schematic right here for anyone interested in the circuit. And I'll also provide a link to, there's some pretty good build blogs on this, which I'll also provide a link to.
Okay, so let's have a look through the board and see where everything is. So first thing of note is there's these pair of end caps here for the, so this is for the smaller of the binocular core, and this is for the pair of ferrite tubes. So you basically snap these out. I'll show you how they get wound and installed later on, but basically these come out, and that leaves two sort of big gaps in the board for the ferrite tube here, and here is where the IRF 530s go, so sort of facing this way, and then they're mounted to a heatsink below. Just some other points of note. So this is where that relay goes. Here's the bias circuitry right here, and there's that PNP transistor right here, which turns on transmit. Not much else to note on this board. Like I said, it's pretty simple, but it'll be a little fun build. There is a space for an LPF in here. So basically, if you want to install an LPF, which you have to if you want to put this on the air, basically that goes basically out here and then back in here, and then finally the signal goes out on this side here. So that's basically the circuit. What I'll do next is I'll wind the toroids, not the toroids, I keep saying that. I'll wind the binoculars, and sort of we'll walk through how they get wound, and then that'll be next. Okay, so here's the end caps off the main PCB. And basically, obviously, this is for the bigger, the paraferrite tubes. This is for the smaller binocular core. And you basically get these out just by scoring it and then using a pair of snips. So anyway, came out pretty easily. So what we'll move on to next is how these end caps actually fit onto the core. Okay, so here's the first step of the end cap installed there. So as you can see, you just got to hold it down and tack it, and then you can make sure that you have a good sort of solder bond between this part and the trace right here. So what I'll do next is I'm going to install the ferrite tubes in here with the internal, the sort of the bushing that goes inside the ferrite tubes, and then we'll be able to get the other side on. So let's do that and come back. Okay, so there's those two end caps installed, as you can see. Now the which end cap goes where doesn't really matter. They're both symmetrical. What is not symmetrical is the actual the PCB itself. So basically what this does, and you can see actually, let me just so there's the bushings in the middle there. You can just see them there. So effectively what this provides is a single turn through the center of the core like this. So basically what happens is this is a single turn that is center tapped, similar to the transformer in in one of my previous videos. But so basically the next step is to now solder these bushings to the end cap. So so let's just have a look one more time at that. So there's no focus there. So there's that end soldered. Here's the other end soldered, and you can see those bushings are in there, but they're not soldered in. So what I'll do is I'll solder those in, and then we'll come back. Okay, so that's both the end caps installed, and the end caps here soldered to the bushings inside there. So you can see, and that's on both sides. So the test of whether you got it right and you soldered everything correctly is you should have continuity. Let me just spin this around a bit. You should have continuity between here and here. There we go. I'm just having a bit of trouble here. There we go. And that's very low resistance between those two. So that's that installed successfully. What we'll move on to next is the other binocular now, and check and get that installed. Actually, looking at the board, it's actually going to be easier to install this relay first, and then the binocular rather than the other way around. Otherwise, it'd be tough to get access to these pads right here. So I'll get that relay installed. Basically, here's the relay here. You can't get the orientation wrong because there's 3 pins on one side and 1 on the other. So basically it goes that way, and you have to basically bend up each of these pins at 90 degrees, and then you solder it down there. So I'll get this installed, and then we'll come back. Okay, so there's the relay installed. Let's just zoom in a little bit so you can see that. So that was pretty straightforward. What I might do next, though, is I'm going to get a a switch installed here on this PTT, and then I'm going to apply power through here. I want to check that the operation of this relay is correct before I install this binocular here, because it's going to be hard to get this out if there's something wrong with this relay. At the same time, I'll be able to test the bias circuitry here without danger of frying the IRF 530. So I'll basically get to the PTT installed. I'll get a couple of leads for power, and then we'll come back. Okay, so that's the power and PTT installed. Now, obviously, this isn't sufficient gauge cable for the actual amplifier, but it's good enough to start with. And I've just got a switch right here. So the switch is off at the moment, so that's PTT off. So I should have basically continuity between the input and the output. All right, so let me turn the... didn't hear the click from the relay, but I believe it did turn over. So now there should be no continuity. I've just turned PTT on. And with PTT on, I should have continuity between the output and over here on the LPF out here. All right, so let me turn PTT off again. I should have no continuity between LPF out and the output. So let's do this. And no continuity. And we're back to continuity between input and output here. All right, that confirms the relays all set up. Let's check now the bias voltage. Okay, so at the center of the screen, you can see the variable resistor, which is used to adjust the bias voltage. It's a little bit tricky because it just spins around and around and around. There are no stop points, but if you turn it, so with the flat spot at the bottom here, that's the midway point. And then if you turn it sort of about 160 degrees this way, so clockwise, that gives maximum bias. 160 degrees this way gives minimum bias. So let's turn that. Oh, sorry, I've just bumped the camera. Bear with me. So let's just turn that to there. You can see the flat spots right there. And now we'll zoom out and we can check the bias. So let's get the multimeter in the screen there. And so you check bias. Well, I should show where I'm actually checking bias between ground and the center tap of the input transformer right there. So let's just check that on the multimeter. Get that shine off the multimeter. So ground and that center tap. You can see that's 2.8 volts, so that's maximum bias. So let me turn it down to minimum bias now. And try again. And you can see 0.11 volt. So anyway, that confirms that the bias circuitry is working correctly. What we'll move on to next is installing the input transformer, and that goes right here. So I'll do the same that I did for this, get one of the sides installed, and then we'll come back. Okay, so there's the first end cap for the input transformer installed. Let me move on to the next one. Okay, so that's both sides installed. As you can see, the bushings are in the center there, and I've checked continuity between, bear with me, so there should be continuity between here and here. But obviously make sure there's no solder bridge across here. The continuity should be through this center tap right here. Okay, I probably should have installed these two electrolytics before I'd installed this guy here. So, but anyway, note the orientation of those. The stripe is negative. So those two are installed quite easily. Okay, so I'm ready to get the IRF 510s installed, and I've tapped a couple of holes in this heatsink here, and basically just making sure I've got this lined up correctly, which I have. And this is the orientation of the IRF 510s. Obviously there's a sill pad that goes underneath it, but I'm just going to tack these down, make sure I've got them in the right spot, and then we can move on. So there's the finished product with the IRF 530s installed there. Leads trimmed, so ready to keep moving. Okay, so I've wound the output transformer just with some simple hookup wire here. Unfortunately, I stripped the wire that came with the kit, but the resistance of this wire isn't much greater than the wire that came with the kit. But anyway, it's 3 turns through the center, so you pass it through firstly this way, both this way, and back through that way, and then back through that way again, both wires. So 3 turns on the secondary side, and then it's a half a turn on each side of the tap on the primary side. So I'll do the same with this guy here. I have checked continuity, just let's show that again. So there should be continuity. Let me zoom in a bit so you can see that. So there should be continuity here and here. And there is, and there should be no continuity between here and here. You can see that's not the case. Okay. Let's move on. We'll wind the input transformer and come back. Okay, so there's the input transformer wound in a similar fashion using the same hookup wire. And again, just for continuity's sake, you should have continuity between here and here, and I've checked that. That's no problem. And no continuity between here and either here or over here. So that's the input and output transformers both wound. So just a few things that remains. There's a couple of feedback resistors that go across here and here, and here and here. And that's pretty much all we need. I will install this jumper here. I'm not going to test it first without a low pass filter. One interesting thing I've noticed here though is there is a space here for R6, which goes across the output of the input transformer. So on the other side of the input transformer, it's not marked in the. There's no resistor that goes there, but there is a place for it on the circuit. So whether that was a previous version or not, I don't know. But anyway, I won't be installing that resistor. Okay, so there's the feedback resistors installed. Well, this one's a bit bent. Let's straighten that up a bit. It's out of focus, my apologies. So there's the 2 feedback resistors installed. Basically, just checking the parts left. Oh yeah, there is, I do have to install this RFC coil up here, which is another one of these binoculars with, I believe 3 turns on it, but I'll have to check. So I'll get that installed up here, and then that should be pretty much done. Okay, so that's our RFC installed. It's held a little messily in place with some super glue. It was wobbling about a bit. It was actually just 2 turns, not 3 turns, as I thought. So that is pretty much that. What I'm going to do is move on to doing some testing. I'll start with a very small signal, low bias on the IRF 510s. I'll get it put on the heatsink, and we'll see what we'll see. Okay, so let's move on and do some testing, but just some points to note on the kind of mess that you're seeing here. So I'm using a thicker gauge power supply cable from a separate power supply that can supply up to 40 amps. So I don't have any problem on the input supply. I jumped over R7, which is, it's hard to see, but there's an SMD resistor right here. And I put a jumper over that just to give me a greater range on the bias voltage. As you can see, I've added a low-pass filter after the amplifier. So this is a 7 megahertz low-pass filter. I replaced the PTT, or if you recall, I had a switch in the previous section, but I replaced that PTT with a link straight to the drain of the MOSFET that's on the... Actually, let me pan down that so you can see that. So this is the MOSFET that's on that's controlled by the ESP32 that turns on when transmitting. So I've replaced the PTT, gets grounded through that MOSFET now. I discovered in the attached links, if you recall, I was talking about a resistor R6 that goes across here. It turns out that that's used for changing the input impedance of the amplifier at various frequencies. So there's a table in the attached document that shows the optimum settings based on a frequency by frequency basis. And then finally, I've still got my 10 watt dummy load on the output here. Obviously, it's going to get taxed pretty highly by the output coming from this amplifier. So let's move on to the test itself. So this circuit here, the exciter is pretty much the same as you saw in the last video I did. So this is outputting around about probably about 3.9 watts, which is more than enough drive for this amplifier. As I said, I have replaced the PTT on the amplifier with a direct connection from the ESP32. So when I hit transmit here, it grounds the PTT line over here. And then I've got my dummy load here. I'm probing the output here, and we'll see the results on the oscilloscope. Okay, so let's hit transmit and we'll see what we see. I'll just hit run stop there so I'm not consistently transmitting. So you can see I'm getting a 7 megahertz signal. It's quite a nice sine wave there. And if you have a look here, the peak to peak is 148, nearly 149 volts, which is around about 56 watts of output. So that's pretty good. One of the things I've noticed is that dummy load that I'm using is getting quite hot, as expected, I suppose. So I guess this is a successful test for the amplifier. So quite a fun little kit to build. I don't think, obviously I'm just using CW here. I don't think this amplifier really would meet the linearity demands of SSB. So kind of CW or FM would be good for this amplifier. But other than that, it was a fun little kit to build. I did wish the SMD components had come separately in the kit rather than having them be already installed. That kind of adds to the fun. But anyway, hope you enjoyed this video. That's all for now.